what we do at when I say Fedora Cloud, so it's actually not any public cloud running somewhere, but it is more about the image which runs on different cloud infrastructure. That is, you can run this image on OpenStack or OpenNebula or CloudStack, or we also generate the AMIs for AWS. So if you look at from that perspective, the major two customers are obviously right now AWS and OpenStack. And for OpenStack, what we create is normal standard QCOW2 images, which can be used in most of the other cloud infrastructure. And we also push the same image into other places like DigitalOcean, where you can boot up a Fedora. So, as you know, Fedora project is a community project. So it's a group of community people along with engineers and people from Red Hat who work on this project. And as part of the project is actually testing whatever we release, correct? So we don't want to give you any broken software, any broken operating system which you cannot use. So, and most of our test cases in general are actual bash commands. So let's say I actually started working full-time on Fedora Cloud in 2014. So part of my job was to make sure that whatever we release is good. So work along with the QA team, who are like, we have a great QA team, but they are always overloaded with work. So what we do is we ask volunteers to download the image or boot up an instance in AWS and log in manually using SSH, and then execute some commands and check the output. Oh, I have this actually. So this is one of the commands. So one of our goal is, or one of the test case what we say is, no service should fail at the time of boot up. Like whatever the default things are should always start properly. So the idea is you log in, you execute the command, and then you check the output, like nothing should have failed. And this is just one example. So there are things like AC Linux should be enforcing. We want that to be working properly. Like different packages must have been installed, things like that. But this, I'm trying to tell you what we do as test cases. And this is how all the images get tested manually by people. And that's the exact point where the failure part comes in. So the biggest problem we got in was about not tested enough. Because end of the day, it is human who are testing the images. There was no automated system at that moment. And like, I think it was Fedora 22 around that time, just before the release date, we made some kind of mistake which made the image unusable in certain ways. And the release engineering team was really, really angry because it happened just the night before. So they had to work really hard to make sure that actual release goes out is working. And in another case, after a few months, we also have a project called Fedora Atomic, or Atomic project. So Fedora Atomic is now the primary output of the cloud group, which is an operating system meant for containers, a bare minimal operating system with atomic states. So that's meant for containers. But in between, we did I think we did a nightly release, which never had Docker. So, and you cannot install a package inside Atomic. It has to come directly from as a part of the operating system. But that was our mistake in a nightly build. So we tried in various ways to fix this. And me being a very lazy guy, that's true. I actually, even though if you see me jumping around, I'm a pretty lazy guy in front of a computer. So my point was, it was difficult for me to every time go boot up try to upload an image to OpenStack, or try to download the image locally and then go through various steps to make sure that a cloud image can boot on my laptop without having an actual cloud, and then test it. That was my condition. And if we look into the next question about the projects, so the way I was trying to solve my problem, I think many of you do the same thing. If I just ask right now, how many of you have any kind of pet project lying around on your laptop or in a corner of your server, which you use to help yourself in a certain part of a job. Do you have any such pet projects? Yes, no? So we all know how this project starts, correct? It starts the open source way, scratch your own itch. So if you have a problem, you solve yourself. That's how most of the project starts. But then the next stage happens. I'm skipping. This is one such example. So it can happen that you will find someone on internet who is trying to solve the same problem in a wrong way. Or it might happen that you will find one of your friend or coworker has the exact same problem and they need some kind of solution. So what do? You generally help them out, correct? We all of us do. And we go like, hey, I wrote this bash script, or I wrote this Python or Perl or anything. I wrote this application. Why don't you use it? And we try to give them this simple project. So what was before that, what was your baby? Suddenly there are now 2 people using it. And instead of 2 people, it can become 100 people. It can be even bigger. So that project can sometimes become something which is there in all of our work laptop or all of our servers places. But at the same time, think after 6 months, think after 1 year, what happens? How many of you actually remember what you wrote as a program, script, or even an email after 6 months down the line? I mean, or 1 year. Do you remember everything you did a year ago? Yes, no, anyone? No. I also don't. So, and then like as system administrator or DevOps, when we manage various these systems, and as I think most of us will agree that all of us have some scripts which helps us to automate some part of our work. How do you think what will happen like when your company or job will require some new guy to come in and actually fill in your shoe? Will they be able to understand what you are doing in that script and the stuff? But at the same time, our main part or work is to make sure that we don't get into those failures at the same time. And for that, we want something which is there in all our computers. In my case, it was all our cloud systems, the operating system which will work on those cloud. And there were mainly those 2 main parts. One is bash, the standard bash. Not all the commands may be available to any particular installation, let's say default installation. And the other thing was Python. So I would actually tell you my talk's primary agenda today is actually to convince you to convert those bash scripts into something more readable, usable Python scripts. So yes, I'm telling you what is my rest of my talk is about. That's it. So this is the actually end result of my whole project. Whatever I actually install and execute your laptop, it will not destroy your laptop. But coming back to my problem, like we had those bash scripts, and obviously, as you know, there are not many people who can come up in the beginning and help us with those tests. So now this is actually a line from a poem called Zen of Python. How many of you know about it? Zen of Python? So for the people who never saw this before, actually going to it's not you, Zainab. So in any Python, if you start Python interpreter and just type this, actually import this in this case. So this is the Zen of Python. This is one way of saying what we love about Python, what we want to do in Python as a programming language. And you'll find there are like thousands of explanations of this particular poem on internet. So one of the major part was readability counts. So think like this. For my work, what I had to do was parse some sort of configuration file. In my case, we started with JSON. and then parse it to a place where we can actually use it inside our code or script. And all of you, at least most of you, are here Bash experts, if nothing else. You know how to work around with the shell. And you can also very easily imagine how easy that is in Bash. And at the same time, how easy it is for a newcomer to come and actually understand what you do. I know it can be done very easily for many people, not for me though, but how easy it will become for the next fresh out of the college student or a sysadmin who never worked that much. So this is one of the example configuration what I have for my project. So in this case, what I say is, it's with a name, it's a VM, and the image which you want to boot up, and some RAM and the username. So I actually had a JSON parsing example from GitHub, but I don't want to show it here because it's too large, like how to parse that thing over. Instead, I'm just going to show what we do in Python. So we already, in the part of the standard library, we have a JSON module. So it provides two different. Oh. Is this? Thanks. So that provides two different methods. One is to load from or directly from file, or the other option is to actually load it from a string, like if you already read that information. And that will provide you a very nice, in our case it was a dictionary of the data we want to read. Yeah. So the next thing, so we just had a tool which can solve us, our problem for us. But that's not the end of the thing. As I mentioned, one of our biggest problem was we never had enough people. Human, in most cases, it's not a computer. Human become the major issue. So it was same with us, that we never had enough people to do the testing for us, other than the automation part, or write new test cases. So what we did next was that we moved out from only those simple commands, but we moved into something, you may think a little bit complex. We used something called Python unit test cases. So that command becomes something like this. If you are coming from any programming language background, you can actually understand most of this code. And what we basically check is that no units, loaded units should fail. That's why 0 loaded units listed as failed. But what is the benefit? What is the benefit coming out of that bash script into a Python unit test case like this? So for answer, I have a question to you again. How many of you actually have code running on your production which can do release blocking? This is a release blocking thing for us, by the way, which is written by second-year college students in India. Anyone? Or you can think about, if you don't have college students that way, you can think about interns. Do you have interns writing release blocking code? We do. Not interns, but volunteers, contributors. Like one kid is from Bangalore, Farhan. One girl, Trishna, she is from second year, again, computer science student from Calcutta. So they wrote most of these test cases now, like over the last 1 year. And the benefit is that they already know Python as a programming language, which they learned, which they use in other places also. So what they figured out, like, oh, we can easily jump in and start contributing to this. And they can already understand like what is the effect out of it, that they can block such a big project like Fedora to be released. So before that, there was almost no one else coming in with new test cases. And almost in the last 1 year, I never had to write a single one, because we just had to document, like, hey, do you want to test this? And someone just came up, I want to write this, give me a day. So by nightfall, we already had the test case written. Then we discussed about it. And all these test cases, by the way, again, are on GitHub with open source license. So later on, if you want to check it out. One of the major feature of the language, what we call is batteries included. That means the standard language comes with a standard library. Python standard library has way too many different modules for you, the batteries. So it has modules to do SMTP, to send out emails. It has modules to like say, if you do not have enough networking related commands installed, it can give you a socket player, which you can use. It has a simple HTTP server module, which you can use to create a HTTP server out of a couple of lines of code. I just can't name all of them. So there are many. One easy way to look what you have. Like, this is the standard Python 3.x. I compiled it in locally, so it will show only the things which are there in the standard library, I hope. Like you can see, FTP leave, stats module, URL leave, unit test cases, mock objects. So there are. Is this visible? So there are various modules available right now for you in Python standard library, which is again there in all of your servers which are running. So another thing, the language, using a complete programming language rather than only bash scripting will help you out, is about errors. So this is again a line from our poem, that errors should never pass silently. So Python as a programming language provides you different various ways to look into the errors in a granular level. So I'm going to open up a code from the same project. This is again part of the, like I skipped few things, but again this is a part of the code coming from the Tunir. I guess, yeah, it works. So you can see, like, we can have exact error case conditions. And most of the Python modules, most of the Python projects you will work with, they will have this kind of granularity, where you can see, you can get into the exact error statement. Even though many times it happens that the developers chose not to go through these details and they prefer to just say file or directory not found. That happens too. So again, this is one slide I actually added. I completely missed about it, but yesterday Baijo told me, like, hey, we should talk about that part also. Debugging. You know how easy or difficult it is to debug in various programming languages. So if you want a full-blown debugger, any part of your code, you can just add actually this one line, which is basically two statements. Import the Python debugger and just start. And then you can go through the whole program. Most of the times I personally just use print statements, but if you want, you can actually go through your whole project. Again, a little bit different thing, Python decorators. This is a feature of the language which provides us many useful solutions. So one of the things we have about our test cases is that our test cases can become today from a getting test. That means that a same test can block a release to a certain extent, where it may not block a release. It still will fail, but it may not block a release. Or a test case can become something only for, let's say, AWS instances instead of all clouds. So we have, or that's only one. That's not only one single test case. It can become more than one. So think about a condition where you have to move suddenly like 100 test cases from one state to another state. Do you want to add if-else loops or if-else statements to all of the source code? So this is just one such example. You remember I said that we had a missing Docker a few days back. So this is where we are testing if the Docker is installed or not. But again, this is not supposed to run on a bare minimal base image. The cloud base image we have, because that's for everyone. Not everyone will want Docker on the image. So this has to run only on atomic images. So what we do is we add something on the top of the function declaration with an @ sign, where we say that if it is atomic, then you go ahead or skip it. So I'm going to a little bit more details about this part of the code base. coming in as functions as first class, helped us to get the Vagrant feature up by next day morning. So it only took us a couple of hours to have the whole Vagrant plugged into the system. And as you can see, we never wrote anything super new. We just called the steps one by one, the way you generally do in a bash script also, but using a proper programming language. That gives us the option, like, the new people, again, the same thing. Anyone can understand, and everyone, even like in our community, went through the point, they read the source code and they said, like, okay, we can put this on production, because if anything happens, almost all of us can go and fix it. Again, that's our mistake as a programmer, but we did that in the first. So we had to clean that up. As I mentioned, from the community, what they're looking from us is that happy users, correct, happy cloud users. So they don't want us only testing for one particular cloud. So today they may want us to test for 2 cloud providers. Tomorrow they want us for the 3rd one, or the 4th one, or the 5th one. It can grow. So I'm going to talk a little bit about a project which we use inside our code base. That is called libcloud. It's Apache it's a project from Apache, and it's already can give you options, same code style options for 30 different providers. That means you can fire up cloud instances over 30 different cloud providers, including AWS, OpenStack, Eucalyptus, and many more. And when I actually used it, I just went ahead with this because I knew there are enough better documentation, and I can use it with both OpenStack and AWS. I never even noticed that it provides 30 different providers. So now I know that when in future we'll be able to automatically test on any other cloud platform, we're going to use the same project, and we don't have to increase our technical depth. This is again another point about C library usage. So Python as a standard, programming language standard, we make sure that our users should be able to use already written C applications, C libraries. So we have various ways. You can use something like CFFI, or you can write your own extension by raw C by hand to manage systems. Like
what we are trying to achieve here in terms of community relations, that you can write entire infrastructure code. We have that sort of faith in community and that sort of inviting to please help us, please help us in contribution.
Yeah, I mean, he's also part of the Fedora infrastructure community. So yeah, other than the passwords and few other things, I mean, few other group variables, everything else is open there for you. So you can take that and start using it in your production system. And yes, we use that thing only. I mean, right now I think all of our production and staging environment is on Ansible, and all of the things are available in the repo. So you can trust our code to be used in your production also. Like any other question, anything related to Python or any open source communities or stuff, or like if you want to start.
And nothing to read about that. So it's about Fabric. Okay. So I teach Python, and then when I'm teaching Python to DevOps, I kind of tell everyone to go and use Fabric. But I always get into this trouble. Okay. So I teach Python 3, and when I go to Fabric, Fabric is not relevant for Python 3. So you end up do everything else in Python 3, and just for Fabric, you have to go back to Python 2.
Yeah. So
David, have you
so what we try to say that if someone is learning Python right now, you should learn from Python 3 itself, because that's the future of the language. And moving from Python 3 to 2 is very easy compared to if you know only Python 2 and if you want to move forward to Python 3. So yes, there are some projects which are still on Python 2 only, and sometimes it's difficult, but the basic of the language is most of the time is same. But the test cases which I showed, those are all Python 3, by the way. Because from a default Fedora installation only has Python 3, not Python 2.
The other thing is, what in slides I saw you said Python 2.8. What's that?
Oh, you got the joke.
Yeah, I know. It was meant to be caught.
I just put it up just to see if people are actually noticing what I'm doing on the screen. So yes, there will be no Python 2.8. Thanks for noticing that. So Python 2.7 is the last major release of the Python 2.x. We'll be doing bug fixing, but all the major releases, all the new features will be always on Python 3.x series. That is 3.6 upcoming. So there will be no Python 2.8. Yeah, thanks for noticing that. Any other question? By the way, if you want a Python resource, like there are so many, we have great tutorial documentation. I also have an open book on the internet called Python for You and Me. You can just Google about it. It's again on restructured text on the readerdocs.org. Yes, please.
Yeah.
Yeah, I can see you now.
Yeah. So question on Ansible. So is this like a competitor for Chef and Puppet, for deploying on cloud, or is it more on your own infrastructure?
You can say it's almost similar thing, and it's not only for cloud. You can use it anywhere in the same way. Okay. And it's written again in Python and has its own features. So I'm not an Ansible expert to tell you which is better or why it is better, but yeah, it is exactly the same.
Yeah, they're in the same space.
Yes.
Okay.
So you can just type Ansible, and these days like too many people are using it, so you'll find a solution. Anything else? Yes,
yeah.
Back.
Yeah, I'd like to add to the Ansible Chef thing. I don't think Ansible is like a direct competitor to Chef or Puppet. We use both of them together. You can use Chef and Puppet for your config management, and you can use Ansible for, having like run these parallel commands, have some sort of a dynamic inventory for your network devices and stuff, right? So they can coexist together, provided you decide the use cases for both of them.
Yes, and Ansible right now can actually do network configuration also. So it's like in Fedora we use Ansible for everything, like in case. So depending on your use case, of course. Any other question?
Hello.
Or
hello. I'm down.
Oh yeah. Okay. Sorry.
Can you throw some light on the project Atomic and how different it is from CoreOS, where people think like every component of the kernel is a Docker container, rather than there are two approaches.
Okay.
Where you have a microkernel or you go with containers. Everything is.
Lala is going to answer. Yeah. So I have someone better than me here to answer. So can we get the mic to here?
Yeah, sure.
So he is from the Project Atomic team.
Yeah, hello. So am I audible, right?
Yeah, you can stand up actually.
Okay, so Project Atomic is in the same space as CoreOS, obviously. But there's a lot of difference in terms of if you look granularity of the project. So Project Atomic actually is a framework. It's not operating system, but using the framework, we can create the Atomic host from the existing packages of Fedora, CentOS, and Red Hat Enterprise Linux, or any RPM-based operating systems, right? So what is the benefit? The benefit is the trust chain we have already, we actually build a trust chain of RPMs. So RPMs are basically, secure, signed through GPEZ and all this stuff. So we create an operating system for containers out of all these RPMs. And the way the name suggests, it's atomic operating system. So it's basically stateless. So when you start the operating system, the whole operating system stays in one state. When you upgrade it, it goes to another state. And if this stuff does not work for you, you can revert back to the previous state. It's like Git for operating systems. So the idea is, when you run containers, right? So the operating system is like the kettle. You should not worry about the operating system much. The attention should be inside for the application, the containers. So how do we create an operating system that will reduce the work of operations guys or system admins, so that they spend less time maintaining the operating systems? So, I mean, that's the basic thing. There's so many other things around, but they're competitors. Yeah.
Any other questions, or else I can go down?
Yeah, no, we're going to wrap the questions for now.
Okay, so
yeah.
I'll be there in the Fedora booth. So if you have any questions throughout the day, come and meet me there. Thank you.
Kushal.
Hey, best of luck. No, and I have to open this up mic. Yes, suddenly I found it. I have something else.
enabled, it's on. And that's how you just turn off a feature. Now, in addition to having a feature enabled or off, you can have a feature be enabled for a small percentage of users. So this is telling us that my feature is enabled for 1% of all cookied users. So this is users that have bucketed by UAIDs. Now, if you want to bucket it by user instead, for example, if a logged-in user sees a module on their homepage, you want that module to be either enabled or not enabled for that user at all times, so that they have a consistent experience. So you bucket by user. And on your application end, you just check whether a feature is enabled. If you are checking for if a feature is enabled for a user, you pass in a user object. So in the same vein, the feature flag is what also enables us to experiment with different features. So instead of having this config block where a feature is either on or off, you might have something like this. What this is telling us is we have a feature, my feature, which has 3 different variations. Layout 1, that's enabled for 1% of all users. And layout engineers, or whoever's pushing code, you are responsible for pushing out your own code. Operations or developer operations people are involved in making tools better for you to be enablers for your own workflow. So the relationship is more collaborative. We talk, you need operations people know the pain points. Developers know, you notice a spike or a change or a shift in pattern in the 404s. You can correlate relatively accurately what push may have contributed to that spike or that change. And then you go through the deploy logs, and you can very quickly find out what commit may have caused that problem. The other vertical lines are different kinds of pushes. So the blue lines are config pushes. In addition to system, so there are a lot of different features at Etsy, of course. There's so each feature development root cause of what may have gone wrong. And these postmortems are blameless. They're not meant to find fault in people. They may be meant to find fault in systems, but they're not meant to ask who broke things. It's meant to figure out what went wrong. Now, you can't ever know. Sometimes there's this instinct to ask, oh, but that's so obvious. Why did you not look at if the test succeeded? Or why did you not look at the dashboards? You could clearly tell 404s were going up. But that's not helpful. If you have one person in that situation, you don't know what to see. So then you ask yourself questions. Are we looking at the right metrics when things get pushed out? Are we having too much to look at, and hence we didn't catch this other thing? So whatever. Those lead to remediation items that you then go and implement. We have a tool called morgue, which is where we document when things go wrong. So if you're part of an organization that has many feature developments, you're not always involved in all of the same failures. When there's many of the failures that happen, network failures, MySQL goes down, I, as someone who is in product development, may not even be aware of. So morgue is a great way to go back and learn from what people found out. If there was an interesting failure, it's a great way to learn something. Yeah, this is just an example of another morgue entry. Morgue, I think, is also on get past someone when you're going to the bathroom, and if you don't know them, it's a little weird. But even if you get to meet all of these people through time, through a whole year, you have a kind of empathy that you wouldn't ever otherwise have. It's hard for you to be mad at someone when you know them. So to summarize the whole talk, a combination of culture plus tooling lets us deploy very efficiently, often in a day. Most times we succeed. Sometimes we fail. And when we fail, we conduct postmortems. Out of postmortems come remediation items. And these remediation items mean they make us stronger. They make our systems more resilient to failure. And there's you can't be stuck in the same cycle. You need external stimulus also to make your system, there's a learning and development group at Etsy that tries to conduct workshops on how to approach problems, how to understand failure, how to approach empathy, how to know, understand your coworkers better, how to understand how to listen. So this is a graph of our current deploys. The yellow ones are web deploys, the green ones are, I guess, blog deploys. But so we have a few deploy stacks, but the most important ones are web and config. So we are able to deploy at least 30 times a day, every single day. We do around 30 plus config deploys a day, so that's 60 deploys a day. Yeah, and that's it. And so we have a lot of technical articles on our deploy process, like if you want to know how atomic deploys work, a lot of the specific tools that I talked about, they're on codascraft.com. And that's all I got. Thanks. I'll take some questions.
Hi. Yeah. Excuse me. Hi.
Yeah.
That was a great talk. Just had one question. Yeah. Why the name Princess?
Sorry?
Why the name Princess? As a pre-prod.
It's, I don't know. It was before my time. I'm not sure. This was when Etsy was 5 or 6 people. And actually, so there's an interesting story. I think it's also on the Etsy blog, but in our deployinator tool, there's 2 buttons. One, the deploy production is called deploy to production, and in a pre-prod environment is called Princess. And it used to be called Save the Princess. And I think it's very interesting because through a lot of iteration, people decided that was sexist, that was wrong. And so now that button is called Get Saved by the Princess. But I don't have an answer to your question, sorry.
Yeah. So I have a question here. So the feature flags looks very interesting way of doing it, but I've actually had experience of trying that. But what happens is over time, your the code really becomes full of features and all conditions and becomes spaghetti. Okay. So I mean, when you use feature flags, do you actually have to spend a lot of additional efforts to clean up all the features that you're using once you know that which feature you're going to use, or do you keep the features on forever?
That's a great question. So we actually had one project where we started distinguishing between, so we are not at that scale yet, where we are at a scale where we don't have these problems, but there was a time where when in the younger days, Etsy would get overwhelmed during Christmas and things like that. And so when we used to have to selectively turn features off. But we don't do that anymore. But that is the only big problem with feature flags, that you need to clean them up. So we have sprints. Like sometimes we just, I think when you're working on a project and you realize that that's part of the project, cleaning up the feature flags, that's the only way I have seen it work. But it works differently across teams. But the downside to it is there isn't that much of a downside. It's just a lot of cruft here and there. But we haven't experienced it being as a problem. We think of it as something we try to clean as we go. It would be ideal to have a more automated or cleaner process to get rid of that. Yeah, but we haven't experienced it as a problem, except there is a lot of switches.
Yeah, so you think keeping that kind of thing is okay? Is that what you're saying?
Sorry, say it again?
Keeping that kind of switches is okay for you?
We don't, I mean, it's okay. It just looks a little ugly. That's fine.
Okay. No, so what happens is, at least with my experience, maybe not designing the switches very well, I mean, the kind of overwhelming switches, and then you really don't even know why the switch was there in the first place.
Yes, so we've had that problem where a lot of people who left Etsy, their names are on config flags. So what we do is we just scrub off those. If they're all on, we just delete those flags. There are some features that are specifically we want to turn them off, so we leave. There's a different convention to those kinds of flags, so they're called feature _ blah blah blah. So we know that these are not just feature flags; these are features or products that we want to maybe turn off sometimes. But yeah, we just scrub them off. But it's ad hoc.
Hi, here down. Yeah, hi. A great talk. You mentioned about the deployment buttons, right? To push to production and to push to princess, right? So which tool you use, and what is your rollback strategy?
So the tool is called Deploynator. It's a tool we built at Etsy, and it's on GitHub too. Our rollback strategy is very simple. We just, if a commit may have caused a problem, we just revert it. So because we are deploying code continually, like our code is very fresh. Whatever's your VMs are pretty much, they're never a day away from master. So if there's a problem, you just roll back, and then you work on your changes, try to fix it, and then you push it back. So yeah, that's only rollback strategy.
Okay, thanks.
Hi. Here we have automation
Because pushing code so frequently that you're so what happens is when say you're at master right now, 3 people have commits to go out. These 3 people make commits now.
Future commits on top of that, rolling back may have some side effects. So
Yep.
how do you handle that?
So chances are, if a commit that you made needs to be reverted, it's very likely that dependency was injected, or that dependency came from someone in your team or you. So in our case, it's rare that a commit depends so strongly on someone else's commit.
Each other?
It's a mix. It's a mix. It's not all. I mean, it's very hard to define. It depends on your domain what a microservice is for you. But in our case, it's a mix of both. There's some monoliths. There's a lot of microservices.
Okay, thanks.
Hi, here down. Yeah. So generally regression test slows us down in the pipeline because they are large in numbers. So how do you choose your regression tests so that they are executed faster and you can go quicker to production?
We try to mostly write unit tests, and we try to avoid integration tests. Integration tests are, of course, incredibly slow. So yeah, I mean, we have a lot of unit tests, and those are almost always really fast. There are a couple of, like, for critical paths to our code base, we have a couple of integration tests, but our tests, I want to say they run, like our QA test suite is the biggest, and I'm fairly sure it's under 10 minutes. So it works fine for us.
Okay. So do you use any tool for code coverage and code analysis?
We are working on some tool based on PHP 7, I think, for static analysis. And we have a bunch of Git hooks that rely on this. Yep.
So what's the team size that you have? The one that handles the tooling. So I mean, there's a pretty much comprehensive amount of tools that you have out there. So what sort of team?
I will be making a guess, so I'll say I don't know. Yeah, but we have a substantial DevOps team, but I don't know an exact number. All right, thank you guys.
Thank you, Premshi. Please take all your other questions to him offline. A quick reminder, the 320 talk by Piyush Verma will be happening at 12:30. Thank you to Intuit for sponsoring the cupcakes and high tea today. Do visit their booth to find out more about what they do. The Fedora project has a table in the expo area. Do meet them and learn more about Fedora. Once again, thank you to Ubico for sponsoring the YubiKeys for Rootconf attendees. And last but not the least, a big thank you to Sequoia Capital for sponsoring the travel of all our Rootconf speakers and the amenities for the participants. We really appreciate your support for the community. Please be back by 11:30 for the next talk.
an on button.
Yes. Okay, so I should remember to turn it on.
Yes. one to the extreme right. In between is mute, but you won't need that.
Hello, check. Great.
Yeah.
Yep. Yeah, can you hear me? Testing?
We request everybody to put their phones on silent, and we request people not to pick up the calls inside the auditorium. Yeah. So please don't use the door to the left. It is very for the speaker. A lot of people are opening the locks and like going out. So please don't do that. If you haven't filled out the feedback forms yet from yesterday, please hand them over to the registration counter by the end of today. A big thank you to Colin Charles for flying down to speak at Rootconf amidst his busy schedule. We'd also thank MariaDB Foundation for supporting Colin's travel to the conference. Teams from Quintype, how do you determine when a DB is at its tipping point? How do you prepare a DB for a seasonal spike? And a lot of other post-mortem questions. And we'll just start off with the keynote for today by Colin.
Hi, good morning. I'm very happy to be here, and thank you very much to Zainab for reaching out. I'm going to talk to you about lessons from database failures. I'm also fairly severely jet-lagged, and the heat hasn't helped. I work on MariaDB server, and have been since the start when we did it at Monty Program, and I've been in the MySQL world, basically hacking on MySQL for more than 10 years and using it for probably more than 15 years. Also worked on Fedora and OpenOffice, and a couple years ago I even won an award. So these slides were prepared a little earlier, but I couldn't help but resist putting this slide here. This actually was probably a quite famous post from yesterday, where this guy said he basically rm-rf'd his entire root directory, including his backups and all mounted storage. So it turns out, I've never seen this in production, but this guy's little hosting company is officially hosed due to a scripting error. My rough agenda today is to talk to you a little bit about backups and verification of those backups. So basically, having offsite backups makes sense, so you don't rm-rf / everything, right? I'll also talk to you about replication and failover. A lot of people tend to believe MySQL maybe is a toy database or doesn't do many things as one would expect. But replication has been one of the key reasons why MySQL has actually become fairly popular and used at fairly large sites. I mean, if you look at the top 20 websites today, 18 of the 20, according to the Alexa ranking, are powered by MySQL or MariaDB or some variant of MySQL. And the other two are actually owned by Microsoft, so presumably they run SQL Server. And the other thing that's fairly new, I'd say maybe only in production use for about 6 to 8 months, would be security and encryption. Security's been around obviously for quite some time, but the ability to encrypt stuff is fairly new in the MySQL ecosystem. So I'll start off with a site called Magnolia. Does anybody remember this, or has anybody used this before? Could I get a show of hands, maybe? Not many. What about Delicious? Okay, so a lot more people use Delicious than Magnolia. But Magnolia probably started a little earlier. It conformed to open standards. It had microformats. It started around 10 years ago. They also had a paid component to Magnolia, whereas Delicious generally was free for all. And according to the post-mortem anyway, they never made any profits. And here's the funny thing about post-mortems. Something as new as Magnolia, I mean, it only probably shut down in 2009. You can barely find information on the internet anymore about Magnolia and why it shut down. In fact, if you Google carefully, I found an old blog post of myself, actually, which is shocking. So they had a complete outage at the end of January 2009, and a couple of weeks later, they realized they had data corruption to the entire UDB, the user database, and they basically said, see lots of, if a DBA does make mistakes, you can actually get around from those mistakes.